Hi guys, welcome to lesson 4 of Fusion. Now, at the end of last lesson, we talked about the revolve feature in Fusion. So now you guys know about the basic sketching elements, extrusion, revolve, which are the basic, or let's say the fundamentals of any CAD program. Now we're going to go into a little bit deeper. We're going to talk about some of the features in Fusion that allow you to do or create a little bit more complex objects. And the first item on our list is going to be the sweep. Now, the sweep is actually very simple to learn, but you need two things for a sweep to work, at least two things. One of them is a profile sketch, which is a closed sketch, a closed contour, let's say. And the other one is actually a linear item, which completes your sweep. So let's start with drawing a profile. Now, I'm going to draw a profile on the front, and I'm going to create something simple like a circle. Okay, let's say that's a circle. Let's give it a dimension. Let's make it 20 millimeters. Okay, now I'm going to create a profile, a linear guide for my sweep to work. Now, I'm going to close this sketch, as you can see, because I didn't turn it into a feature, I can still see it. And this profile, I'm going to do it on the top plane. Okay. I'm going to create a line at the center, at the origin. I'm going to say OK, then I'm going to create a tangent arc, just for fun. Something like that. Okay. I'm going to say finish. Now I can see both of my sketch items. Then I'm going to go and select sweep from the create menu. Sweep. Now you can see on the right hand side, sweep menu opens up. Sweep menu is asking me to select some items. Now the first is the type. We're doing the single path for now. It's asking me to select the profile, which is my closed contour. It's asking me to select the path, which is my open contour. It says change selection, which means these path items and these profile items, if they were made from more than one curve, more than one line, it will be selected as a whole. It's telling me the orientation will be perpendicular. This means this profile will turn along this path. You can also select parallel, which will also do. And if I'm creating a new body or if I'm adding to something. Now the analysis we'll get to later, but let's start with the single path. So I'll select my profile, then I'll select my path. So this is my sweep. As you can see, the profile is turning, and you can see this from this cutaway, that it's following the path. Okay, so the profile is always normal to the path in this perpendicular orientation. If the orientation was parallel, it would create an error because of the type of the path that I'm using, but we'll do that on another path type. Okay, now with this single path, single profile object, I have a few options, and one of them is the distance. This is not a millimeter, it's given as a whole unit. It's from 0 to 1. And I can change this, I can make it shorter. So even though I have a path, I might choose to sweep to some point that I'm defining. So I might do something like this. As you can see, the distance is almost half. And I can do the whole thing. Okay. It's given me a taper angle, which I can change. So that'll make it more like a, as it follows the path, it can grow, or I can make it shrink. Okay. So that would be the taper angle. So if I was making a hook, for example, I might do something like that. So that would be something like a hook. Okay. And I can give it a twist. The twist won't be so apparent with a circle, but we'll do another one with a square so you guys can see it. So I'll select OK, and I'll change it. I'll change this to a square. So we can have that as an example as well. Okay. Now I'm gonna start the edge of my square right there. I'm gonna say 15 by 15. Okay. I'm gonna say finish. As you can see, Fusion is giving me an error, a warning, let's say, not an error. And it's telling me that the reference is lost. Okay, so I have to go back to my sweep, say edit feature, and it says missing profile. So I have to reselect that profile, the new profile, and that's what my sweep looks like. Okay, now let's see if this is going to hit itself. Yeah, so we'll do that on a more basic path. But for this example, we can look at the twist. So let's say a 10-degree twist angle. Now you can see maybe 10 is a little bit too low for you guys to see. Let's make that 30. Okay, you can see that the square is turning 30 degrees until it gets to the end. That's important because this angle defines what will happen at the end of the path. So if I would say 90, you can see that the square has turned a whole 90 degrees until the path has ended. What would happen if I say 180? Okay, that's what it looks like. So that's a 180-degree turn. I can combine these. I can say do a taper and turn 180. So that's what it would look like. Okay. Now, let's zero those. Okay. So we have our single path sweep with a single profile and a single path. Now let's look at something which is quite important. Now I'm going to make this, I'm going to go into my first sketch. I'm going to change the location of my square. Actually, I'm going to delete this one. I'm going to draw another square, which isn't touching the path. Okay, the size doesn't matter for this example. I'm going to say finish sketch. It's giving me a warning about my missing profile, so I'm going to edit the sweep. And I'm going to say this new square is my missing profile. Okay, now if you're not touching, if the square isn't touching the path, you need to be aware that the whole shape changes. So the path is acting like an offset in this example. Okay, so this is not sticking to the path. The path is offsetting itself. Okay, so you might get weird outcomes if you don't pay attention to this. Okay, let's look at that again. As you can see, the path is on the inside and the sweep is following something like an offset curve. Okay, it's not sticking to the path. Now let's make a simpler path so we can look at the other feature. Let's modify this a little bit. Let's open this up. something like a large, two large radiuses should be fine. Let's say OK. So the path is adapted. Let's see what happens when we say, instead of perpendicular, let's say parallel. Okay. Now, as you can see, this profile is now normal to itself at all times during the path. You can see that this plane at the end is parallel to this, and all along the path it stays parallel. Okay? So it's not rotating, it's not using the normal of the path. So that's the difference. Okay? Sometimes this is useful for creating certain objects. Usually though, you will usually use perpendicular. Okay? So that's what we have. Now this is the single path. Let's do one with a guide curve. Okay? So let's edit this path sketch. Okay? And let's create something similar. Okay? But a little bit different. Let's do something like that. Okay, let's say finish sketch. Okay, now let's go back to our sweep. Let's edit our feature. And instead of single path, let's select path plus guide rail. Okay. Now it's asking me also to select the guide rail. Let's select the guide rail. Okay. So now the extend includes the perpendicular to path, but it also includes something new. It says full extent. So when I select that, it uses both of these curves, the longer curve actually, to create the path distance. As you can see, if I don't select full extent, it finishes at the shortest path. Okay, but when I say full extent, it takes both of these paths and goes to the end of both. It's almost like there's a line between the endpoints of these two paths, and that's where it finishes. Okay. Most of the time you will use perpendicular to path because you want to keep that normal, keep the finish as a normal to the path, but it's good to know. As you can see, there's a small deformation right here. Okay. This is the important part of using path and guide rails. You need to be aware, let's look at it from the top. You need to be aware that if both of your paths don't match in terms of their curvature, you will get this. You will get this breaking in your path. Okay. Now, there's another option which is important here. It says profile scaling. Okay. Now we're using scale. What happens if we use stretch? Now you can see that the profile, even though it's getting narrower towards the ends from the top, it's using the full thickness of my profile. If I select stretch, if I select scale, it scales according to the distance at the end. Okay, it's looking at both of the paths. It's seeing that the two paths begin with a distance and they keep getting closer to each other. So it does the same thing for the thickness. Okay, but if I select stretch, it only does that from the top, but not from the side. Okay, and when I select none, you can see it's only using the top path and not the second path as a change in shape. Now this doesn't usually have any meaning if you use none for profile scaling because you lose the ability to use both of the curves, both of the paths, basically. So you usually keep this at scale. That's or scale or stretch. Okay. Now that's the example. Okay. There's also a path plus guide surface. We might get into later. That's a little bit more advanced because you need a good surface for that to follow. But these two, the path, single path and the path guide rail, are commonly used. Now, anytime you're using pipe, creating pipes, hoses, cables, sweep is the easiest way to create this. Okay. Okay. Now let's delete this sweep. Okay. Actually, let's delete the second one as well. Now, I'm keeping this first sketch hidden for a reason, because I'm going to show you guys something else. Now, if your profile is something simple, if you're creating a hose, a pipe, a tubing, a cable, instead of creating a sweep, Fusion allows you to do something very simple with a command called pipe. Okay, it's under the Create menu. As you can see, there's this thing called a pipe. There's also a small icon on the menu. Now, when you click pipe, all you need is a path. Okay, it's only asking you to select a path. Let's select that path. And it's giving you the option of different section types. Now, these section types are the only ones available under pipe, but they're a little bit configurable. So if I use circular, okay, then if I click hollow, it will create something with an internal negative space, and I can change my section size as well as my wall thickness. Let's say 1. So now I have a pipe. Okay, I can do the same thing with a square. I can create my section size and give it a wall thickness. Okay, so I can do the same thing with a triangle as well. Okay, in a triangle you have another option which the other two don't, is you select where the path is controlling. And what that means is once you click triangle, you have to be aware that it's taking the middle of that triangle as where the section, where the profile starts to sweep, let's say. Okay. Now that's important because if you want to have the triangle follow, let's say, the bottom edge, you have to create a sweep. It's not going to allow you to do that. Okay. So keep that in mind. In a square and a circle, that's easy to calculate because the center of the circle and the center of the square is pretty easy to understand. But the triangle might get confusing because you can see that it's not the exact center of the triangle. Okay, so keep that in mind. So the pipe is a simple command when you need some simple sweeps without any complex geometry. Now, on our first sketch, let's create something a little bit more complex. Instead of a square, let's do something with splines. Okay, so I have this weird shape. Select OK. Now let's try and sweep this. That's my profile. That's my path. Okay. Now I have this. This would be considered half organic, but the idea behind using stuff like this is you can create extrusions similar to Play-Doh. So you can have different types of extrusions that are not straight, that follow a path, that are organic. Now, I've seen this being used in places, like window ceilings or the English name, I don't know, carton-pierre, okay, in plaster moldings, let's say. So you can also do that with a sweep. Okay, let's take a break. Okay, so that's what sweeping looks like with complex shapes. Okay, let's start a new design. Now, let's talk about loft. Now, sweep is a little bit simpler. Loft is a little bit more complex, but it's not hard to understand. It just needs a little bit of experience. Okay. For a loft, you need two profiles, and you don't need a path always. But we're going to do the examples now. Now, let's start with the top. Let's create something on the top. Now, let's start with something simple like a circle. Okay, so let's 40 millimeter circle. And let's create another sketch on another plane. So I'm going to do an offset plane from the top to, let's say, 100 millimeters, or let's say 80. Okay, so I have a new plane, 80 millimeters above my first sketch. And I'm going to create a sketch on that plane. And this time I'm going to create, actually, let's create a polygon. Okay, 6-sided polygon. Let's make it 7. So that's my 7-sided polygon. I'm going to finish the sketch. Now I have two profiles, 70 millimeters apart, two different profiles. And I'm going to go into Create menu, and I'm going to select Loft. Now, as you can see, the Loft menu is a little bit different than the Sweep one, because you have a lot of different options for creation. And to understand these, it might take a little bit of practice. Now, the first thing it's asking me is a profile. It wants me to select the profile. So I'll select this one and this one. And it has created a loft for me. Okay. Now, I didn't select any rails, any guides for this one. And that's all I'm going to do. I'm going to select OK. So I have a loft going from a circle to a 7-sided polygon, and I can use this. However, this might not be exactly what I'm looking for. So what I might need to do is I might need to modify this to create something a little bit more interesting, let's say. So I delete my loft for this example, and I make my sketches visible. Now I want to create something that expands a little bit while it's lofting, then contracts. Okay. That means I need to make a path or a guide rail for this. Now the way I do that is important, and I'm going to demonstrate that. I'm going to create a sketch. I'm going to create this sketch on the right plane. Okay. And I'm going to do something like, for this example, let's do something with this spline. Okay, I'm going to click outside my profiles. I'm going to select OK. So this is what I have. Okay. I'm going to go and say create, finish my sketch, going to create, select loft. For my profiles, I select this one and this one. Now, when I go to select my rails, I select my sweep. Okay. Now, this is important. This is the thing that you need to watch out for. It says on the bottom right-hand side, let's do that again. It says the selected rail does not touch all of the profiles. This is important. Unlike sweep, in a loft, your guides rails need to touch the profiles. So how do I do that when I'm sketching from the side? So let's go and edit my sketch and let's try and do that. So I'll look up my sketch. Now, if I try to bring in this point to touch my profile, it's very difficult. Fusion is not giving me any type of help here. So what I do in these circumstances is I create a projection of this curve, this polygon, onto the sketch plane that I'm using. So how do I do that? If I go into create, and if I select project and include, I will see certain options. Now, the first one is project, the second one is intersect. These two are the ones that I use mostly, okay? Now, project, let me talk about differences. We talked about project a little bit, but there's a certain amount of difference here, okay? When I select project, I get two options. I get specified entities and the whole body, okay? Now, I don't have a body yet, but I do have specified entities that I can select. So I can select this curve, and as soon as I do, you can see a very faint purple line appear. So if I select OK, Fusion's telling me that this line would be this long when it's projected onto the current sketch plane. But I can't use this line because it's not giving me a line, it's not giving me a point on my on the profile that I need for this spline entity to touch the profile. It's giving me 2 points, but those are not on the line, so I delete that. But if I go and select intersect, and if I select the same line, as you can see, it's giving me a point exactly where my sketch plane is cutting this line. So I select OK. Now when I bring in my point, I can touch it, okay? Now, there's a small constraint appearing, which is telling me that it's locked in place. So I need to do the same thing on my circle. So I select my circle, I go and select intersect, and I have a point. Now, if I had selected project on my circle, and if I'm at the center, if this new sketch where my spline is on the center of the circle, I would get a point right there. Let's do that. Let's cancel the intersect. Let's go into project, and let's select the circle, okay? When I click it, because my sketch plane is going right through my circle in the center, this point is also the topmost point of the circle. So this would also help, but it's not good practice because you might not go through your circle right in the center like this plane is going through. So intersect is always the better option in these circumstances. So I use intersect, select OK. As you can see, the intersect doesn't have a purple line going through it. It only has the 2 points where I'm cutting this circle with my new sketch plane. So I select my spline, bring that over there and lock it, and I get my constraint. Now, these 2 profiles are being touched by my spline. So I finish my sketch. I go into Loft. I select my 2 profiles, okay, and in my guide rails, I select my spline. So now I have this loft following my guide rail. As you can see, the loft is on my guide rail. Okay. Now, this is the part that needs, or you guys need to practice, because with these guide rails, you can do many different types of loft examples, okay? And that's not all, okay? You can move the trajectories of your loft. Now, because we're going from a 7-sided polygon to a circle, each of these vertices, these points, are diminishing into a line. The circle doesn't have any vertices on the outside that can directly relate to these 7 points. So what Fusion is doing, it's doing an approximation, okay? But that approximation is not something you have to use. You can manipulate it. You can make these go into a closer pack of points. And this will change your shape drastically. Okay, something like that. As you can see, now the center part of this loft is much more circular, and the back side is much more angular. Okay, so you can play with these according to your needs. Okay, and Fusion is giving you this. If you look at, there's a red line that's giving you an understanding of where that normal is. So when you're playing with it, you can see that red line is moving. That's like the shortest distance between those 2 points. And if you want to make a perfect loft, you can play with those and make it so that this line is almost normal to the circle. Okay, this totally depends on what you're trying to achieve. Okay, there is no right or wrong here. It's only about what you're trying to achieve. Okay, so something like that. Okay, now there's one more thing that you guys need to watch out for in a loft. Most of the time you won't have to play with this, but sometimes you will. And that's how the loft begins and how the loft ends. Now, if we look at this loft from the side, okay, you can see it says for the first profile, this one, okay, it's putting names. If you guys look at the first profile is the one below, second profile is top. The first profile says it's only connected, okay. What if I change this to direction, okay? Now, as soon as I change the direction, it's giving me a number. This is in millimeters with an arrow. Now, if I were to pull on this arrow, okay, you can see very minimally that this loft is getting straighter. Now, maybe it'll be easier to understand if we get rid of using the line And if we cancel this, let's make a loft without using our guide curve. Okay. And let's say, instead of connected, let's say direction. Okay. It's much easier to understand in this way. Now, if I pull on this, you can see that the beginning profile is getting more of a power over the ending profile. Okay. So as the more I pull on this, the straighter it begins, and the less I pull on it, okay, this is the ending point, the less of a strength it has. So if I didn't want a uniform loft, I could do something like that. I would want the ending to be much more sharper. Okay. Now, let's go back to connected on this one, and let's change the second one for direction. And this is the reverse. So I can pull on it like that, or increase the size to get a fatter loft, something like that. So this could be an interesting water glass, I guess. So you can play with these according to the loft that you need. Let's say okay for this one. Okay, so I have a drinking glass. Okay, so the loft has a lot of power on how you control it, but it doesn't end here for the loft. Now we're going to do another example with the loft. Let's get rid of this one. Now let's create another surface, another offset plane above this one. Okay, 80 millimeters above. Let's sketch on this. Okay, let's this time let's make a square or a rectangle, a little bit offset to the side. Let's say okay. Now I have three profile sketches, and let's create a loft with these. My first profile, second profile, and third profile. Now, as you can see, the loft is shaping. The more profiles you add, it's creating different kinds of features according to the profiles that you select that are on your agenda. Okay, so you can see the twisting that's happening because of these control points, which you can, like I said, control a little bit. Yeah, I can pull on this to make it straighter. Okay, maybe pull on this a little bit, something like that, and pull on this. Okay, but each profile you add is affecting the ones that are behind it. Okay, so the shape is adapting. Now, you can see that I have connected on my first profile. On my second one, I don't have anything. And on my third, I also have connected and direction. I also have these. You can see these boxes. Now, if I were to do something like that, you can see it's affecting how the shape is performing. And it's created a weird okay, got a phone call right there. Now, if you look at this, it's created a weird shape. Now, these icons are telling Fusion which profile I'm moving from to which profile. So when you're selecting the profiles in sequence, when you first open the loft, that's the one that Fusion is taking as the sequence. But you might not have selected all the profiles according to sequence. Here's where you can change that. So you're saying from profile 1 to profile 2, from profile 2 to profile 3. and profile 3 to profile 1. Okay? Now, this is where it should end, so you don't want it to go back onto yourself. So you say profile 3 to profile 1, and it will jump like this. So it's going from 1 to 3, then to 2. Okay? So keep that in mind. We're going from profile 1 to profile 2 to profile 2 to profile 3, profile 3 to profile 3. Okay? So you might need to change them. You usually don't have to change them if you select them in sequence. So keep that in mind. Now, if we would select direction here, it's the same as we talked. We can control how the loft is acting in terms of its start and its end. Same goes for here. So we can make it start slimmer, something like that. Okay, so it's looking like a flame, but that's the controls you have. So that's the profile part. Now, the rail part, let's add a rail, which is this one. Okay, this selected rail does not touch all of the profiles. So we have the same problem. We're touching these two, but we're not touching the top one. So it's not using that. Okay, let's make one that touches all of them. For an example, let's cancel this one. Let's go back into our spline sketch. We have a problem. We created the spline sketch before we created the last profile. So what do? We select our late sketch and let's see if we can move it. We can't move it. Let's say if we can move this one. Okay, let's move the plane first, then the last profile. So now we have our sketch, spline sketch as the latest one. So when we edit it, we can see it. Let's start with the last point. Actually, let's do our intersect first. Let's do our intersect. Okay, intersect this line right there. Okay, then let's select the tangent arc. No, select the spline. Okay, select that one right there and do something like that. Okay. Now, I wonder what it's going to do when these two splines are not tangent. So let's see. Select OK. Select loft. 1, 2, 3. The rails. Okay. The rail is not smooth. Okay, that means there is no tangency here. So we need to modify that. Let's see if we can modify it by adding a tangency to those splines. Actually, let's control them first before we do that. Let's make sure there's something like that. Okay. Now let's add a tangency. It's over constraint. Okay. Select OK. Let's see now if they're smooth. 1, 2, 3. Oop, that's a point. Okay. Now let's select our guide rail and we have weird shape. Okay. Now you guys just saw something and I should talk about that. You can also end in a point. It doesn't have to be a closed contour profile as such. You can also end in a point. Okay. That's how you make sharp objects with lofts. You end in a point. Now, that point, even though it's sharp, it can be controlled. You can see that it says sharp for the third point. But if I say point tangent, okay, then I could control it. But this time, let's get rid of that rail. Okay. Now I have that rail is causing a problem with that tangent point, but if I select it like that, instead of the sharp, you can see it's coming to a tangent at that point. Okay, these curves are all coming to a tangency at that point. So that would be a curvature way of ending to a point. Sometimes sharp gives you the results you need. Sometimes it's the point tangent. So this is looking like the tip of a brush. Okay, I could use this as the tip of a brush, for example. Interesting. Anyway, so that's loft. You have many controls in loft. You can create many different shapes using different profiles. Now, you don't always have to have offset planes that are parallel to each other. Sometimes you need to have planes that are not parallel to each other. So a good example of this would be, let's start a new design. Let's create something on the top plane, path. Let's sketch on the top plane. Let's create an interesting path. Now I'm going to use an arc, a 3-point arc, to start my path. Okay, and I'm going to use my tangent arc to create something like that. Okay, now I'm going to use this as my lofting path. And why would I need to use that? Well, this path gives me the ability to create the plane along path feature, or let's say construction plane. So what I do is I select that, select this, and I make sure I'm at the furthest point on the path for my first sketch. I select OK, then I go into construction, I say plane along path, I click that again, and I'm gonna make one here. Okay, I do the same thing, make one along there, and I'll do one at the end for this example. Make sure I'm at the end. Okay, now let's start with the first plane. Create a sketch. I'm gonna make something that starts with, actually let's start with a square. Now instead of using this square, I'm gonna go into rectangle. I'm gonna say center rectangle. So I know I'm at the center for this one. Okay, so that's my center rectangle. On my second plane that I created, a sketch on it. I'm gonna choose a circle for this one, something like that. Select OK. On my third plane, I'm going to say sketch. And for this one, I'm going to go back to my center rectangle. Okay. And on my last one, I'm going to end at a point. I don't actually have to draw a point on this one because the path has that point, but for the sake of having a true loft that is representable, I'm going to put a point. Okay, let's do a loft with these. So this is my first one, second one, third one, and fourth one. Okay. Now I have this weird shape. I'm not following the path exactly. What if I click rail and select it? Of course, I don't touch all of them. Going inside closed contours does not mean you're touching the profile. It has to be on the edge. Okay, but what can I do? I can play with the connected. direction. Okay. I can make it start a little bit more. No, I don't like that much. Okay, what else can I do? Well, instead of going to a sharp, I should go into, well, point tangent. Let's say if I increase that. No, I don't like that. Now, this is telling me that I don't have enough profiles. So I'll say cancel, and I'll create a little bit more profile sketches. Okay, I'll create one there, and I'll create one right there. Okay. Now, sketch on this one. I'll continue with my center rectangle for this one. Okay. And for this one, I'll make it, I'll make center rectangle. Actually, let's make an ellipse. Let's make an ellipse for this one. Something like that. Okay. Now I have more profile sketches for my loft. Let's say 1, 2, 3, 4, 5, 6. Now I have something that's following my path a little bit better. I'm not exactly sure about the shape, of course. Looks like a mutant banana, but it's fine. If I wanted more control, I could always draw guide rails, but this is fine for this example. Okay, so I have multiple profiles. I have a total of 6 profiles that I can control. Let's increase the tangency. It's almost like a, looks like a bird. What do you call that? Mouth of bird. Interesting. Okay, so that's how you create lofts. You need a lot of experimentation, but it's fun, and you can do many things with lofts. Most of the items that are modeled in CAD, in Fusion, that have organic shapes have multiple profiles that are turned into lofts. So it's the most common way to create organic objects. Okay. Now, let's close this one. Close that one as well. And that one. Okay, so now you know what extrude, revolve, sweep, and loft stands for. Now, the rest, the rib, the web, are not important for us right now. They're used for plastic injection molding most of the time. If we have time, we'll get into that. It's more of an advanced topic. Now, the emboss is useful for text, for raising text and images. We'll talk about that in a later video. The hole and thread we're going to talk about, but these box, cylinder, sphere, torus are simple objects to get you to start modeling. We don't usually use these. They're mostly used for beginners, but keep in mind these are there for that reason. The coil we're going to talk about later, but before we get into move forward with the create tab, we're going to talk about some of the items that are in the modify tab, which are quite important actually. Now, some of them you saw me use during my lessons, but we're going to get into the specifics of these a little bit. And for that, we're going to start with a small box. So let's create a rectangle. Let's extrude that rectangle. So we have a box. Now sometimes you'll see different colors in Fusion. That's because most of the time I use something called display component colors. Now this is important when you have multiple components on the screen. Fusion gives them a default setting of gray, but if you apply display component colors, each component will have a different color. It's easier to separate them. Okay, now let's move on with the gray. Now the first thing in our modified tab is called the press pull. Now what that enables you to do is to pull on surfaces or to press on surfaces. Okay, now as you can see, the dimension starts from my original point. Okay, now this is where I started, 0. So let me move this negative 10 millimeters towards the inside of the box, and let's say OK. Okay. Now I get this small press pull icon in my history. You can see here down below. Okay. If I press pull on this again, you can see it starts from negative 10. So Fusion knows that a press and pull has been applied to this surface. Okay, so I move it outside 15 millimeters. Okay, it doesn't create a new icon. You can see it's the same surface, but if I were to do it on another surface, say press pull, I'll pull this about 75 millimeters. Okay, it's still not putting a new icon. Okay, that's important. If I were to edit this, edit feature, now it's saying 15 millimeters this way, but it's not giving me the other 75. This is important to keep in mind because if you apply multiple press and pulls, you might get distracted. You might lose where you were. Okay, so be careful when applying press pull. It's good to adjust a single surface because the history is there, but multiple surfaces on the same object might cause you to lose the timeline. Okay. Now, what would have happened if I applied an extrusion to the same surface? I can right click on the surface and I can say extrude. And I can extrude that surface. Now this, every time I extrude on a different surface, okay, is giving me an icon in my history, so I can delete them to go back to the original object. Okay, but when I delete the press and pull, the 75 millimeter that I had pulled didn't go away. Okay, so if you're pressing and pulling the surface, do it once. Okay, do it on a single surface. Okay, now something else about the press and pull we're going to talk about after we talk about our next object, which is the fillet. Now, fillet is something that you will use a lot together with the chamfer. Now, the fillet, let's select these three edges, and with my arrow, I'll create a fillet. Now, the fillet is used almost in every product because you don't want sharp edges. You don't want people cutting their fingers. So even if it's a little, you use a fillet. For example, this is a 10 millimeter fillet, and on this edge, I'm going to apply a 1 millimeter fillet. Okay. Now this is to stop people from cutting their fingers, but this is for aesthetic purposes. Okay, so there is a difference in the way you apply fillets. That's more of a design issue rather than a fusion issue. So you guys can talk about that in your classes, studio classes maybe. But in Fusion, fillets are an important part of your modeling. And something you have to get used to is applying fillets at the end after you finish your main modeling features is where you apply fillets. And the reason for that is fillets will affect your model. For example, I have these two fillets applied to this rectangular prism. Okay, let's say I want to extrude this top part. As you can see, the fillets are not being extruded. Okay, the fillets are not being extruded, and if I didn't want this to happen, this would not be a good way to extrude it. So I would have to go back to the place where I applied the fillets, do an extrusion, okay, and pull my history tab back. But then I would lose the position of my fillet. So I would have to go to Edit Feature, reselect them, pressing Control or Command on Mac, reselect them, and then Fusion might remember. Do an edit. Sometimes Fusion remembers it, wants you to check it. I'm not going to change anything. I'm just going to say OK, and the warning is gone. So when to apply fillets on your models is critical. When I press and pull this, you can see the press and pull command is a little bit smart in these instances. Unlike extrude, press and pull knows that you're actually pulling on the surface and it pulls the fillets with it. However, here's the problem. Let's take a
Okay, so this is what you get when you pull a filleted object, okay? So there's a difference between press pull and extrude when you have an object as such as this. The same goes for pulling the fillet. So let's press and pull the fillet. As you can see, you can change the dimensions of the fillet with a press and pull command. Okay. Now you can see you're not seeing anything in the history. So be careful what you do with press and pull. You only get the press and pull once in your history timeline. Okay, so that's the simple fillet. So let me delete the back fillet and let's edit the fillet to look at what else we have. Now, as you can see, it says free edges because I selected free edges. Now, because I selected free edges at the beginning and gave them a fillet, it's using the same fillet size for all the free edges. But if I remove that selection and if I select a single fillet, give it a dimension, okay, then select the plus sign, then select another line and give it a different size, it will use the fillet command for different size fillets, and you can do multiple fillets as such as this. Let's do another one for the bottom edge. Let's give it a 5. See, you have different fillets intersecting at the corner, and these fillets are designed in such a way by Fusion that they interact with each other without a problem. Okay, now there is a box next to the fillets, as you can see. This controls the tangency. Okay, now G1 is the tangency, but G2 takes the curvature into account. What that means is the curvature is controlled by the surfaces that are coming together. So in a box form where it's 90 degrees, these two surfaces, it's not going to make a huge difference. Okay? With the curvature command, what you get is surfaces before turning into a fillet move a little bit more forward so the tangency doesn't start exactly at the edge. Most of the time you will use tangency because you want it to start right at the edge, but sometimes on certain types of products you might want to use curvature. Let's look at it from a different angle. You can see that there is a wrong one. There's a slight difference on where the curvature starts. Okay. Now, there's also this thing called the radius type. Now, let's get rid of two of these. Okay, so we have this edge only. Okay, we have a radius type of constant. So the radius is 10 millimeters from the beginning till the end. But we can change that. We can say chord length. Okay, so we have a chord length. If we change this number, okay, chord length decreases. Okay, that means the length of this line, the length of the circle segment is being controlled. Okay, so this line is 10 millimeters, and we can check that by going into measure. Okay, we can just select this. Okay, this is according to 10 millimeters, including the tangencies. Okay, so if we select our fillet, we can say that the chord length is only 10 millimeters. Okay, and that also includes the tangency, so it's a little bit more. But you can see it. A better way to check that would be this. See, this point to this point will be exactly 10 millimeters. Okay, so with the tangency, because it's a circle segment, it's a little bit more. Okay, so instead of using a radius, you can use the chord length. It's mostly used in machining, not modeling, for machining purposes, but sometimes it's useful. And there's variable. Okay, the variable is your control of start to end. So you can start with a 10 and you can end with a 5. So let's say we're starting with a 10. As you can see, the start is 10 and we're ending with a 5. So this would be a variable fillet. Okay, we can make it even smaller to see it better. Okay, so sometimes you might need your fillet to slowly disappear, maybe into another product, okay, into another body, for example. So you can use a variable fillet, and you also can control the ending point. So it doesn't have to end at that specific point. You can say 0.8. Okay. Type that 0.8. Okay, and you can say start at 0.1. No, let's actually do this. Maybe it's okay. Endpoint position is fixed. Oh, okay. So I have to select somewhere in the like that. That's if you have 2 points, it won't let you control it. I forgot about that. You need to have more than 2 points. So that's how you control a variable fillet with multiple points. Now I can move this. I can move this to 0.2, for example. So I have an increasingly thinner fillet. Okay. So that's how you can control a fillet, a variable fillet. Okay. Most of the time you will use constant, but it's good to know. Sometimes you might have to use variable fillet. Okay. Now the tangency weight issue is not something that you will use most of the time. If I make it this fillet a little bit bigger. Now the tangency is the way you connect to your faces. So if I were to say tangency 0.1, as you can see, it will only create the fillet at the 0.1 mark. we consider the whole thing a 1, remember. 0.1 mark would be something like this. Then it will go straight until it reaches the other 0.1 mark. So as I come closer to 1, I'm getting something that is closer to a radius. And when I'm at 1, I'm getting a full radius, okay? So I never use it. Usually it doesn't give me that fine control, but you might need to use it for some instances where the model requires. So it's good to know. It's good to know. Okay. Now, there's a corner type. Now, the corner type is what we talked about. When we have 3 edges, and I can keep edges, adding edges when I click on multiple edges within the same fillet. The way I do that is from choosing rolling ball, which is similar to actually rolling a ball on the edges, to setback, okay? Now the setback expands the fillet into the corners of the surfaces, okay? In most products, you will see rolling ball, okay? But there are times when you don't want this corner to exist, and that's when you use a setback, which creates a more wholesome corner as such. You can see that the radius of the fillet is also included in the surfaces. That's the difference. See, a sharp surface compared to a setback surface, okay? Now, if you change from tangency to curvature, you will also see that this corner expands as well, okay? It's not only the fillets on the edges, but also the corner expands, okay? So it changes that as well. So this is a fillet. It requires a type of experimentation, but you should definitely try it out. Now, let's get rid of this fillet. Let's also look at chamfer. Okay. Now the chamfer is similar to a fillet, but it has less options in terms of control. I selected this edge. I'm making a chamfer. I'm making it with the arrow, but I can also write numerically, okay? Now this is a 45-degree chamfer, okay? And you will see this in some products. You will actually see a chamfer like this. Then you will see a fillet at the edges of these chamfers to make it soft, something like that. This is what you will see most of the time, okay? But within this chamfer, let's edit the feature, you have some options. Now the first is type. Most of the time when you click an edge, the chamfer will extend both ways, but sometimes you might not want an equal distance, you might want 2 distances, which also means you're not making a 45-degree chamfer anymore. For example, something like this. This is controlled by distances. So the top distance is now 5 millimeters, the bottom distance is 15. You can see these here, 5 and 15, okay? You also have the option to create a distance and angle. So let's say we go back to our 15-degree, but the angle, we want it to be, this is 45, but we want it to be 30 degrees. So you can also control this by not giving it 2 dimensions, but giving it a single dimension and an angle. You can also flip this, okay? You want to do it to the other side, you can flip it. So it's good to know. Now the corner type exists here as well. Let's go back to our equal distance. Let me add the other edges by pressing Control or Command on Mac. See, this is just as the rolling ball fillet. This is the chamfer corner type. There's a miter corner type where the edges end up in a point. Okay. There's also a blend. Okay. Now the blend depends on the angle. Of course, the 45 degrees here create a hexagon. But if they were not 45 degrees, it would be broken, as you can see. So it doesn't like that. It wants it to be equal distance. Okay, so you can see that. Now, miter is used in manufacturing a lot because this is what happens if you sand, for example, free edges on a box. This is what you get. You don't get this unless you sand the corner as well. So, and if you sand this corner a little bit more, you'll get this. Okay, so it's good to know. Most of the time, you might want to choose to use a chamfer just so you don't have a point here, which might be dangerous for in your products. It might hurt someone. So you usually don't leave it as such. But it's good to know that you also have these options for your chamfers. Okay. You can also create multiple chamfers in a single feature. Let's say this chamfer is 5. No, you shouldn't press OK, you should press the plus. This chamfer is 10. And another one on the bottom. This chamfer is 15. Okay, so you can have multiple chamfers. When you try and change it to miter, it might not look like a point there because of the size of the last one. The point is up here. And the same goes for blend, as you can see. If they're not equal, Fusion can't blend it into a hexagon. It blends it into something like a fillet. Now this is very useful because you will see this on products as a blending type, which can also be machined. But watch out what happens here. As you can see, this goes in to the product. Sometimes you might not want that. So keep that in mind, that blend with chamfers is something you need to be careful with. Okay, as you can see, this hump is not on the same level as the bottom behind edge. Okay. Okay. Now, so fillets, chamfers. Now, these three you will use a lot. Now, the fourth one, the shell, is very fun when you're creating objects with internal features. Why? Now, when you select shell, you will get a very simple menu. All you have to do is select the faces that you want emptied and give it a wall thickness. So, let's say I want to create a box and I want this box to have 1 millimeters of wall thickness. What Fusion does is it goes through all of the surfaces, then moves them 1 millimeter inside and creates another closed box, and then subtracts that box from your original box, and you get a shell. You don't only have to choose a single face, you can do multiple faces. If you press Control, Command on a Mac, select multiple faces, you'll get a shell which has 2 sides open, and you can do this on 3 sides as well. Okay, so that's how you create empty spaces. But here's the thing, if you create a fillet after a shell, you will have a problem. Why? Because now this is your solid body, and if you wanted the outside to have a fillet, okay, you will move into your object. Okay, this is not what you want. So what you need to do is you need to go before the shell item, create your fillets on your objects. Let's say I want to create a fillet there, this edge, this edge, this edge, and this edge, and I'll give it 5 so it looks like a soft object. Then I'll move back into my shell. Okay, now Fusion also included the relative fillet on the inside, okay? So this looks much more realistic. So keep that in mind. Like I said, when you apply the fillets is critical. Okay, so that's the shell command. There's not much more to it. The only thing you can do is you can, instead of going inside, you can go towards the outside, okay? You could say, I want to go 1 millimeter towards the outside, okay? And it makes the shell, instead of giving the wall thickness to the inside, it gives it to the outside. So this would, the whole internal object that you did expanded 1 millimeter towards the outside, then it was shelled. And you can do both sides, basically. So you can give different thicknesses to the inside and to the outside. You have these options, and that's it. You don't have anything else. Now you have used values being stored here if you need to. Okay. If you create multiple shells, you can say last used. Okay, and it will recall that. Okay. And the last one for today, we're going to talk about combine. Now the combine is very easy to understand, but for that to work, I need to draw another body. Let's draw another body on the top, and I'm going to have it be just a rectangle. It's not important what type of a shape it is, okay? Now, instead of doing a cut, I'm going to say new body, okay? So I have two bodies currently being intersected, but I want to convert these into a single body. What I can do is I can say combine. I can say this is my target, so I want this box to join this. So the target is the one that you're applying the feature to. So the first one you select is the target. The second one is called the tool, okay? And the operation is join. Do I want a new component from this, or do I want to keep it in this same component? I want to keep it. Do I want to keep the tools in the combine? You can do this. Let me open up body so you can see. I have my two bodies selected. If I say keep tools and say OK, okay, now the tools are there, but these are joined, okay? Now that means the tool and the joint body is separate, okay? So I kept the tool. I can use it for something else, but I also have a joint body. This used to be my target body, my shell, okay? If I didn't say that, let me open up those both. If I said don't keep the tools, you can see my bodies. When I say join, it goes into a single body. So all I have left is my target, okay? Now, that's join. Let's do cut, okay? The cut is very similar to cutting away during the extrusion process, but we're doing it after the fact, and there might be reasons for this. Let's say, okay, now I have a single body. The tool was used to cut away my shape. I can also say keep tools. So I have this cutaway now. I have my cutaway. I also have my tool, okay? And the last one is intersect. Now the intersect makes sense. I'm gonna uncheck keep tools. It's what's intersected between the target and the tool that's being kept, okay? So the intersection point was this. My tool is gone. My target is gone. And this is what I have. This is the intersecting body. Okay, so the combine is relatively simple. Okay. Now we're going to get into components, bodies, what their differences are. But for this week, I think you guys should practice these two new features, the sweep and the loft. You might as well check out pipe while you're at it and understand press pull, fillet, chamfer, and shell together with combine, okay? Because on Wednesday morning, we're gonna do in-class practices, so I'm expecting everyone to be in class with just these tools, okay? So, I'll see you Wednesday.